All right, here we go. So I'm going to get into, I think we're just going to barely begin SQL today. But before we do that, first of all, I want to compliment you all. Everybody turned in their 3 tables for Netflix assignments. And I've graded all those now. But what I wanted to do, some folks did a really good job and really understood some of the concepts there. Some folks had a little bit more difficulty. So what I wanted to do is I wanted to go over that assignment with you today before we get started on anything else. The hardest thing for me in doing this assignment is limiting myself to 3 tables. When I think about Netflix, I think about a lot of different tables for Netflix. So we're gonna make a little bit of a bigger database design than just 3 tables. And I think that might be helpful because I think you'll see, what a Netflix database might actually look like. Let me move my little video here. And a lot of you started with some of the obvious ones, and I think that's great. I think, that's where I would have started as well. Ooh, I don't like that color. Let's do a different color. There, okay. And one of the ones that you all started with was some variation of customer or viewer, the person watching the videos. So we're going to put a customer table in there. And that's certainly one of the tables that you would have. And another table that you would have, or another key table that you would have would be, let's call it the content. I like that word better than videos. But, these would be 2 of the tables. You have customers who are looking at content. That's what Netflix does for a living, is they connect customers with content. So those are 2 of the tables that you have. And some of you, the other popular table that you all had, or that many of you had, you called something, and I like the name that some of you gave it, you called it watch history or something like that. Watch history. And basically that told what customers were watching what content. So, if you were going to do 3 tables for Netflix, these might be a good set of those 3 tables to do. And, if you were looking at the attributes of these things, for a customer, you would generally have an account ID. You would generally have a name, and you might break that down into last name, first name, all that good stuff. But we'll just call it name for now. Address, phone, all that good stuff to identify the customer, to be able to build the customer, all that good stuff. And you might even have a credit card. Okay, so you might have all that good stuff for customer. And, this is not exhaustive. I'm going to make it a little smaller because I want to be able to fit a lot on this diagram. In fact, you know what? Let's do this. Space is going to be a premium on this slide, so I'm planning in advance here. So something like that might be your customer table. Okay, so let's do content next. And here you might have things like an ID number, something that will uniquely identify that content for Netflix purposes. You can call it a content ID or a catalog number or something like that, but it's some number that uniquely identifies that piece of content. You might have a title. You need a content ID because I was just telling one of your classmates here that I watch a show called I like MMA. I'm into martial arts. I like an MMA show on Netflix, it's called Kingdom. But if you search for Kingdom on Netflix, you'll also get this Korean horror show called Kingdom on Netflix. So title is not unique. So we probably need something to more uniquely identify the content. So we use a content ID there. Okay, but you might have the title, you might have the year released, all that good stuff, right? So, that might be something that you have for content. You might have some other things there, but I'm going to leave it at that for now. And then your watch history. Make this one line because I'll add some stuff there. Your watch history would have to tell what customer watched what. So you might have an account ID there that says which customer, and you might have a content ID there that says what they watched, that tells what they watched. God bless you. And you might have the date that they watched it, and you might have the duration that they watched it. All of that might be part of your watch history. Okay. So, this is the kind of thing that ties the customer together with the content. What did they watch? So who can tell me what the key field would be for this watch history? What do I need? Which of these attributes do I need to uniquely identify a single record in this watch history? Yeah, Zach. Yeah, you certainly need the account ID and the content ID. You might even need the date because if somebody watches something. You might even have date time here or something like that, because they could watch it more than one time in a day. So, but yeah, you're here for the seating chart. I warned these guys this was going to happen. So let me pause my recording. That's very good. All right, so we're back on the recording now. We had somebody come in and do some seating assignments here in line with our new COVID policy. But, what I did here is, we identified the keys for these things. Account ID uniquely identifies a customer record. The content ID uniquely identifies a content record. And we need account ID, content ID, date, and time to uniquely identify a watch history record. Okay, so we've gotten a start on 3 tables here. Now we have some relationships between these things. Each customer let's make that line a better color. Each customer has a watch history, right? And a watch history we'll call this specifies a particular piece of content. Okay, so there are relations here. Can anybody tell me how those relationships between these relations is established? How do we know which piece of content a particular watch history record applies to? Yeah, by the content ID. So what do we call that content ID in watch history that identifies a particular piece of content? Yeah, Michael. Sorry? Yeah, it refers to the content. What do we call something? Yeah, the foreign key, right. So what we're going to do is we're going to identify that foreign key. We'll color code it. This refers to this. And likewise, we have another foreign key in watch history. Account ID, exactly right. Make that a nice purple. And that refers to the primary key and customer, which is account ID. Okay, so here are three tables. That's all very well and good. We've got three tables for Netflix. We can make some more tables here. So, some of you did something called, let's call it, we could call it seasons. We'll make this one a little one. You said if there's a TV show, that TV show, if the content is a TV show, that TV show may have multiple seasons. So what we can do here, season number. We'll make this new table seasons. Okay, and obviously there's a relationship here between the content and the seasons. Let's make that. And the relationship there is that a particular piece of content had seasons, right? What's the key for the table seasons? Or what would be a candidate key for the table seasons? What fields would uniquely identify seasons? Which one? Season number, yeah, but season number one, you might have season number one of Seinfeld or season number one of Friends. So you need the content ID also, exactly right. And to implement that had relationship, we need content ID as a foreign key pointing to content. Yeah, foreign key is content ID, and I've highlighted that in red again because that refers to the primary key in content. And season number, exactly right. Yeah. So we would need to make we'll make season number bold because that's part of the primary key. Anything that's bold is the primary key for that table. Right? So we need both of those things to be bold. So that those are the primary keys that we need. Any questions on this so far? How am I doing so far? You all right? Okay, another thing that you guys did was you did episodes. Because each of these seasons has multiple episodes. Now, an episode could have a title, right? So we might want to include title as an attribute under episode, because these episodes might have a title. So this might be another table that we have. We might ask ourselves whether we need a separate seasons table or not, or if we can just, write a query that tells us what unique season numbers are in the episodes table. So, that's a design decision that we could make with the database. We could say, okay, I really don't need the seasons table. I can get rid of that and just connect the episodes directly to the show and include season number, right? But in this case, in order to uniquely identify an episode, we need to know the ID of the show that it's part of. We need to know maybe what season number it is in. Actually, we probably don't even need to know the season number because the episode number could be unique. But if it's episode 8, it could be episode 8 in season 1 or 2. So yeah, we'll leave the season number in there. All right, so we've got this episode state. Exactly. Content ID is the foreign key. And truthfully, in this particular case, season number would be a foreign key as well, because season number uniquely identifies, content ID and season number together uniquely identify the season. Title can be not unique. Okay. So now there was another field that fewer of you used. But I'm going to call this thing, I'm sorry, not another field, another relation. I'm going to call this credit. Okay. And a credit might be for a particular piece of content. It has the role that somebody played. They might have been a producer, they might have been a director, they might have been an actor. If they were an actor, it might identify their part. Yeah, so I'll stop there for now. And that might apply to a particular piece of content. Yeah, good. Yeah. Well, let me hold off on that one, because we're going to think about that one a little bit. We might want to include the name of the person, or if we want to relate that to other things, we might want to make that a separate table also. So that's a decision that we can make. Yeah. Certain what? Yeah, good question. I'm gonna put that in the parking lot because I'm gonna get back to that question. But the reason we might not want to include information about the person is that person might be in a bunch of different shows, right? And we don't want to list the information about that person for every show that they're in or every piece of content that they're in, right? So instead of doing that, we might want to have, we'll make a separate table or a separate relation. We'll call it talent. And we might want to refer to that talent with an ID here. And then in this talent table, we'll have the talent ID, and then we'll have that to be black. There we go. Yep, got to fix that. Fortunately, this isn't a PowerPoint class. There we go. We'll have the talent ID. We'll have the talent name. We might have their age. We might have other information about that talent ID. About that talent in general, And this talent ID in credit, sorry, the primary key for talent, for the talent table, need a new color. orange doesn't show up very well. Let's go to more colors here. We'll use a pink. How about pink? There we go. Talent ID is the primary key for the talent table. And there's a relationship between credit and talent. I'm going to call it acknowledges. That's a good name for it. There's a relationship between credit and talent. You know, the credit acknowledges a specific talent. There's also a relationship between content and credit. You know, there might likewise be a relationship between episode and credit. You know, if somebody's in one episode and not in the show, right, they might be here. So we might need some more foreign keys in credit. Let's make that a little bigger. We might need an episode number or a season number and an episode number. Because those would need to refer to a specific episode. So those could be blank if they're in all of the episodes, or they could be a specific episode and number if they're only involved in, you know, some set of episodes. Okay. And they might play different parts in different episodes. That's also possible. Okay. So this is a structure here. Is this the exact structure that Netflix uses? I don't know. You know, it might be. But it certainly makes sense, right? Who's credit? Anybody have any comments or thoughts on this? All right, so we need to show the talent ID here as a foreign key. So we'll get our pink color here. There we go. How's this looking so far? You know what? We need season number. Season number. And episode number here too, because a watch history a person might only watch a limited number of episodes of a show. Okay, so how are we feeling about this so far? So if you included any of these tables, you know, you would have gotten full credit. The important thing to realize here is that because what is good about this design? What is good about this design? Or what makes this a reasonable set of tables for Netflix? Other than foreign keys, there are no fields that appear in more than one table. So we don't have the opportunity for a value to get changed in one table that's not changed in another table. Okay, so when you design your database, you want to make sure that you're not repeating any non-key field in more than one table. For the key fields, for the foreign key fields, they should be there to implement some relationship between your tables. So you'll notice that every line that we have on this diagram that specifies a relationship between two of these tables has a set of fields that are a primary key in one table and a foreign key in the other table. Everybody okay with that? Any questions on that? Okay. Now, when we build a database, and we'll find this out, we do have to make sure that there isn't an opportunity for primary keys and foreign keys to get out of sync. And you'll hear a term later on that we're going to use when we get into SQL called referential integrity. What referential integrity means is that if I delete a record in episodes, and as a result, the content ID, season number, and episode number no longer exist in episodes, it will make sure to cascade that delete to other tables that refer to that record. And that's what's called delete referential integrity. There's also update referential integrity, which means that if I change a value in this table, that change is cascaded to other tables that have that value. Okay. So a new term for us here is referential integrity. That's the thing that makes sure that our keys will always continue to be in sync and be matched. So when we actually build this database, we need to set up referential integrity between our foreign and primary keys to make sure that they stay in sync. Okay. So, these are like, I would say these are probably like the core tables of Netflix, based on what you guys came up with. There are obviously other things that Netflix adds. One of the ones, I'm sorry, there is one other thing that you guys noted and included in your assignment that I should mention. Genre. A lot of you guys talked about genres of different content. So I'm going to include that one also. You have genre. And one way we can do that is we can have genre name and content ID. The primary key for genre is genre name, and it refers to content Now, why don't I just put genre name under content? Why don't I just make that an attribute of content? I could do that. That's a possibility. I could make genre name an attribute of content. But what I find in Netflix is that a lot of content falls under multiple genres, comedy, adventure, crime, drama. So, you don't want to feel, this is another mistake that some people make. You don't want a field in here that can take on multiple values, you don't know how many values that field is going to take on, right? So there can be many genres associated with a single piece of content. You want a separate record for each one of those things. Now I can identify a piece of content under as many genres as I want. And all I have to do is add records to the genre table to do that. Does that make sense to everybody? Do you understand why you don't want fields that might have multiple values within a table because you don't know how big those things can grow? Okay, so I break genre out into its own table. And we'll talk a little bit more about this when we talk about database normalization. But, you know, this is, in this case, I can have each genre. You know, I can have multiple genres pointing to a particular piece of content. And I can easily write a query that finds all content in a particular genre. You know, select, join genre with content, and select content title, content.title, where genre name equals action. Project content title on the join of genre and content, where content ID equals content ID, and select genre name equals action. Okay. So this is as far as you guys went in your assignments. I think this covers everything that everybody included in their various Netflix tables. You know, this is kind of a summary of where you guys wound up. And you can do some very interesting types of queries. You can say, okay, you know, based on watch history, I see this customer is watching a lot of things that are in the action genre. Customer, you may also like these other things that fall in the action genre that you haven't watched yet. Gee, Netflix does that. You know, they recommend things. Or you can say, you know, this customer has watched these 5 things. By the way, those 5 things also match something that's been watched by another customer, and that customer also watches these other things. Therefore, the first customer may also like these other things. So, you know, if you build this database properly, you can start to do some data mining on this data to make recommendations for your customer. And that's exactly what Netflix does, right? People who liked this also liked this. Okay. Any comments on this? Any questions? Anybody have any other tables that come to mind? I'm gonna add a field here. How about that rating? Customer might rate the show after they watch it, and we would want to include that rating here as well. All right. So, you know, another way we can mine this database, you know, once we've laid this out, is we can ask questions about the talent. Say, how many people are multi-credited talents? You know, how many are writer producers? How many are actor directors? Okay, so you know, we lay out this database, and we're not necessarily thinking of all those questions right away. But if we design it properly, as we've done here, you know, without repeating fields and things like that, and with breaking these things up into appropriate tables, we can start to think about how we might mine this data to get useful information. So I'm going to save this out, and this will be on our Canvas page, and we'll stop this here. But you know, if you provided any subset of these, you know, and you organize them in a reasonable way, you got full credit for this assignment. And if you made some little mistakes like duplicating fields in multiple tables and things like that that weren't keys or something like that, you'll see that you got less credit. If you had any fields that could have infinite numbers of values in them, like if you put genre under content, you know, I commented on that as well, and you'll see that in your assignment. Okay, once again, any comments or questions? Any thoughts? Any other tables jump out at you? Yeah. Oh, yeah. So glad you said that. Yeah. Yeah. That's a really good one. Because you guys did do that one also. You had subscription plan ID. Okay, so we can add subscription plan ID to customer. I like that. And then we have, thank you for commenting on that. I totally forgot about that one. And then we can have subscription plans. And we'll make that a foreign key in a minute. We'll have subscription plan ID. Now I gotta make this black again, hopefully, and not bold. Oh, plan name. Monthly cost. Yeah, plan name and monthly cost. Obviously we can add more things to this. And I'm running out of colors, but I'll make this a nice brown, hopefully. Yeah, there we go. Brown is good. And that's my primary key for that table. And it's also a foreign key in the customer table. Now, why don't we include plan name and monthly cost in the customer table? Why do we need a separate table for it? Or a separate relation? Yeah, because we'd have the same data all over and over for each of the users that has the same plan, and that would be an opportunity for that information to become inconsistent, right? If we change the pricing on a particular subscription plan, if we raise the price on that subscription plan, we don't want to have to change it in every customer record that has that subscription plan, right? By the way, there was one more that you guys had, and this just reminded me. Profiles. You guys noted appropriately that when you log on to Netflix, it asks you which profile you want to use because you might have multiple people using the same Netflix account, right? Yeah, one customer has multiple profiles. Like they say, when I log on to Netflix, it says, who's watching Netflix today? Is it John or Ben? Ben is my son. And thank heavens they have separate profiles because he and I have totally different tastes in what we watch on Netflix. And, that would have an account ID. A profile ID, right? And those would be part of the primary key. And then it would have a profile name. You make that black, that should be black. And then we would have this relationship that says, I'm not big into anime. My son loves anime. So, you know, I'm glad we have separate profiles. Recommendations based on what my son is watching. All right. So that was another one that you guys also included. And obviously we wouldn't include profiles under customer because each customer can have multiple profiles. So that could have a whole bunch of values. You know, my daughter occasionally watches my Netflix, not so much. Okay. And you know, you can certainly make this even more complex. You know, we can imagine even more tables. You know, like one of the tables you can imagine is a billing table. You know, that shows the customer, you know, the customer being charged for the plan every month. You know, you can have their billing table. You can have a table that shows how the customer reviewed different shows and things like that. But this is good for now. Like I said, I think this captures now, hopefully, after Hannah's reminder, hopefully this captures everything that you guys included in your assignments. And you know, the process that we went through here, by the way, is a bit of a database design process because you guys brainstormed what you thought would be part of this database and you included it in your assignments. And now we're together and we're integrating that into a design. And I'm reviewing that design with you. And you're telling me, hey, wait a minute, you forgot this, or you know, Hannah remembered that I forgot to include the subscription plans. And that reminded me that I forgot to use the profile. So, you know, I review this with you. And the good news about that is I haven't built the database yet. I haven't, you know, done the schemas yet. You know, we've come up with a good database design here based on consensus, and now we're ready to implement. Okay. So that's a good illustration of the process. And, you know, I've kept these diagrams simple, but later on in the semester, we'll learn how to add the detail to these diagrams that's necessary to drive it down into an implementation. All right, so who can tell me what my next step would be after I draw this diagram, after we figure out what these tables are? You know, what would be the next thing I would do? Any thoughts? Well, the next thing I would do is I would define my schema. So what's a schema? A schema would say the name of each relation and the attributes that that relation contains. Right? So I had my recipe schema. I gave you guys the recipe schema last class. We could build a schema out of this diagram, right, for Netflix. And then what would be the next thing we would do? Yeah, that's basically right. We'd figure out what questions we would want to answer with the schema. And then we'd specify how those questions would be answered from the schema. And when we think about the questions, we might figure out, oh gosh, I realize something is missing here. You know, I forgot something. And I'd have to add that in to answer that question. Right? So that's all part of the database design process. All right, so now we've designed our database. You know, we're happy with our schemas. Now we have to implement our schemas. And that's where we are starting today. And if you remember, when we talked about SQL, I think I forgot to download my slides. When we talked about SQL, we talked about two things, two pieces of the language. And I mentioned this briefly, so I don't expect anybody's going to remember it. But does anybody remember what the two pieces of SQL, the two different languages were in SQL, two pieces of language? This is a memory test, because like I said, I mentioned it very briefly in one of our earlier sections. So, any ideas? Okay. One of them corresponds to the schema called data definition language. Or D. Okay, we're going to start with that one. Yeah. Yeah, the other is DML. Do you remember what the M stands for? Manipulation. Yeah. Data manipulation language. So the DDL is the language that we use. So that's how we tell SQL the structure of the database. The data manipulation language or DML is the language that we use to implement the relational algebra. To answer the question. Okay? So let's look at that. We've got 25 more minutes. Good. Okay, we'll start this today. We're not going to finish it today, obviously. But here we go. So the DML provides the ability to query the information and to add and delete tuples, data instances to and from the database rather. Okay. The DDL defines what the structure of the database is. It defines views of the database, which means, how that database looks to different users. And it also allows us to specify the referential integrity that I discussed between the keys, between tables. Okay? So, these are a couple of the terms that you'll hear in SQL. And SQL also includes things for what's called transaction control, which is making sure that if there are groups of statements that need to be executed successfully together, that those statements are executed as a unit. And if one of them fails, you can get back to a state before those things executed. So, we gave the example of doing a funds transfer from one bank account to another. A transaction would be making sure that the funds, before the funds leave the one account, they appear in the other account. And before they appear in the other account, they leave the first account. Those two things taken together have to be a single atomic operation. And the thing that controls that is called transaction control, and that's part of it. Authorization. Authorization has to do with who can do what on which portions of the database. Who has permissions to do what, who has permissions to access what portions of the database. And we're going to talk a little bit about later on. We're going to talk about how we embed SQL in procedural programming languages. So this is what we're going to cover over the course of discussing SQL this semester. And we've got a unit now on introduction to SQL. We've got our next unit is intermediate SQL, where we're getting into some more of the sophisticated pieces of this. And then our final piece is advanced SQL, where we get into whether we embed the SQL or how we embed the SQL in a program versus running it standalone. Okay, definition language. As I said, that's the thing that allows us to implement the schema of the database. We have to be able to specify, the structure that is associated with that logical schema that we define, and say what values the attributes in that schema are allowed to take. Are they numeric? Are they character? You know, what's the format of the various attributes? Then we have to specify the integrity constraints. You know, if there's a relationship between two tables, how do we maintain that relationship so that if one value gets changed, the other value is likewise changed? Or if one value gets deleted, the other value is likewise deleted. Another thing we do in DDL is, in order to optimize or speed the questions that we ask of the database, we may index certain fields so that the records can be accessed more quickly. So primary keys, for example, we may want to build an index of those primary keys so that the records associated with those keys may be found more quickly. So DDL allows us to do that by specifying indices. Okay, and security and authorization, physical storage, all of that can be controlled via DDL. All right. So, you know, we've got this customer database, you know, that consists of account number and name and the phone number and all that good stuff. For each of those things, for account number, for name, for phone number, you have to say what the domain is for that field. So these are the domain types in SQL that are supported in SQL. And there are more of them, and you can see those in chapter 4 of your book. Okay, but the primary ones are characters. You can have fixed length characters, strings, or variable length. Integers, you know, and generally, when you use an integer, you make it an integer rather than a small integer. The only reason you'd use a small integer is if you feel like you need to save storage. For our purposes, we're going to be using primarily integer. You know, if we're making an integer type, it'll primarily be an integer rather than a small integer. You can specify a numeric format. And you have, when you specify a numeric format, you can have essentially the precision of digits, and then the number of digits to the right of the decimal point. Okay. Now, I'm going to caution you, you know, SQL, Structured Query Language, SQL stands for Structured Query Language, or SQL for short, is a standard from the American National Standards Institute, ANSI SQL. Okay. Standard is a very strong word for what SQL is, because if you look at some of these data types, some of these data types are supported in some versions of SQL and not supported in others. And one of the things I have the hardest time with sometimes is if I move from one of these systems to another, I find that some of the data types don't convert. You know, that's one of the things that doesn't convert. But these are from the standard SQL. So we're going to, when we work in SQL Server, we might find some of these don't quite work the way that it says in this slide. So I'll just caution you on that. But, you know, these are the domain types. You know, and as I said, for some of our exercises, in this section, we're going to be using our grades database, and our grades database will look like this, and I'll show you that in just a minute in SQL Server. Okay. Now, when we have a relation schema, the way we implement it in the database is through what's called a create table command. Okay. So I'm going to go to SQL Server here. Let me look at the time here, make sure I'm. Okay, SQL Server Management Studio. If you guys are running this, you can bring this up. This is the platform that we'll be using to do the SQL programming that we do. Bear with me a second. I'll show you in just a moment. It's this little icon down here. It should be on these machines actually, because I did make sure these were loaded. And when you guys log on, you'll make sure your thing says Windows Authentication. And when you hit connect, that should log you on immediately. I have to do something else on my computer. Yeah. Yes. Thank you. Thank you. That is absolutely correct. Okay, and when you bring up SQL Server, you'll see a screen that looks like this. It has a little navigation bar on the side. And I actually have two databases loaded right now. I have the grades database and the census database. I'm going to write a new query here. And the create command has several different options. One of them is to create a database. And, for our purposes, what I like to do, just to make things clearer, is for the keywords, I'm going to use capital letters, and for the parameters, I'm going to use lowercase. And you can see that when I do that, it says command completed successfully. And when I refresh my view of the database by right-clicking on database and hitting refresh, you'll see that I ran that SQL command and I've created a blank database here. Okay, so you've just learned your first SQL command. And we've created a database where we can play around a little bit with DDL. Okay, so I've created a blank database here. Okay, and this will let me save that query. I'm not going to save this query because I don't need it again. I'm just going to throw that away. I'm going to say no to saving that. But now what I do is I select my blank database. This is the database I'm going to work in. And what I'm going to do is I'm going to create a new query. And I'm going to do a create table query. And we're going to name this table customer. And our table customer, here is the syntax for create table query. You'll see it has create table, it has the name of the table, and it has an open parenthesis. And you can indent your next lines. You can make this good programming style. And what we're going to do is we're going to define each of the attributes of this customer table. So we've got customer ID. And we're going to make that, we'll tab twice. We're going to make that a character. Let me look at this for a second. Yeah, we're going to make that a character field. We're going to say character 20. Okay, so that's my first field. And you might say, why did you make that character instead of integer if it's a number? You can make it an integer, but for various reasons, I'm going to make it a character for now. All right, so I specify that first field. Customer last. I'm going to make this a varchar. I'll make it size 40. Okay, go back to my Netflix thing. Yeah, address. You know, I'm just filling in relatively arbitrary things here. Oh, no, this one's char 2. Right, we want the state code, so we'll put char 2 there, you know, NY, NJ, CT, you know, all those standard state codes. Of course, if this were international, you know, we might want to call this state or province. And we might make it different. We might make it char 5. You know, we would have to do our research there. Zip. This one I'm going to make an integer. Okay. So we can specify those pieces. And no. When we say integer, it's the size. The size is machine dependent, really. It's whatever size integer your platform supports. Okay. And credit authorization, I'm going to make this numeric. And we're going to say that customers, you know, there's a rule here. We can say that customers can have up to an 8-digit, let's make it a 10-digit credit authorization with 2 decimal places. Okay. So when I do this, and hopefully I did this correctly, I close my parenthesis. I'll close it on the next line. I like keeping things neat. There we go. Hopefully, if I did this correctly, you know, and I'm running in the blank database, I can execute this query. Beautiful, I did it correctly. Okay. And I can look at my tables. Oh, wrong database, sorry. There we go, and I will see that I now have a table called customer because I just ran this query. What do you think is in that table right now? Nothing. It's an empty table right now, but I've specified the structure of that table by using my create table command. Okay? I'll give you all, does anybody need time to catch up on that? Does anybody want to try that themselves before we move on? Raise your hand if you need more time. I got one hand up. Good, 2 hands up. All right. Yeah. Sure. Okay. Can you read that okay? Yeah, no, I can read. Oh, I see. The database. I'm sorry. Yeah. Let's use parentheses or a bracket. Oh, there you go. Yeah. Yeah. Let me try to do that. The other thing you guys can do, by the way, and I did this even before we went pandemic. If you have trouble seeing in the back, join the WebEx. Okay, because sometimes I can zoom this stuff and sometimes I can't. So let's see. Control scroll. Oh, there we go. Yeah. put it full screen. Good, I've got a new technique now that I can use for this stuff. Good to know. Yeah, so once again, all this stuff is parentheses. This is not C++ or C. They like the braces. Apparently, SQL likes the parentheses. And by the way, we're going to stop there for today, and we're going to pick this up on Tuesday. But I wanted to make sure everybody at least got to the point where they created their first table in SQL. So this is your accomplishment for the week, is you've created your first table. Okay, just a reminder as you guys are finishing this up is you do have another assignment due on the 30th, which is 1 week from today, and that's the relational model exercises. You know, this is essentially just doing relational algebra for an entertainment database, which looks surprisingly similar to what we just did for Netflix. Okay. And when you all are done with your create tables, you know, we're done for today. And I'm going to wish you all a great weekend, great rest of the weekend, great weekend.